turn cold, and how you can rekindle the heat that you never really appreciated until it was gone. Like most appliances, ovens and stovetops are actually fairly simple machines. They use a series of electrical circuits to energize different components at the proper times. As always, a great amount of caution should be used when troubleshooting and repairing electric appliances, to keep that last meal from being your last meal. Fortunately, almost all of the components of an electric stovetop or oven can be tested while disconnected from the electrical supply. If you don't have one of these babies, or don't know the first thing about how to use one, I've got you covered. Let your fingers do the walking and come on down to applianceassistant.com and have one of these shipped to your front door while you learn how to use it by watching a video. It doesn't get much easier than that. Okay, enough of my yapping, let's get to the fixin'. Let's start at the top, or more appropriately, the surface. Whether you have a glass top or coil elements, the idea is the same. Turn a switch to send electricity through the burner element and bingo, you've got heat. What could go wrong? Well, actually there's 3 things that can go wrong. Either the switch doesn't close and allow electricity to flow to the burner element is broken in some way and won't allow electricity to flow through it, or the circuit is not energized with the correct amount of electricity needed to do its work. Heating elements used in an electric range need 240 volts to operate. In fact, when a heating element is on, it is constantly supplied with 120 volts. It is only when another independent circuit is applied, used to cycle the element on and off, that heat is actually generated. First, let's check the power supply plug. Your plug will have 3 or 4 connections, 2 hot connections and 1 neutral connection. In this case, there is also a ground connection. Set your meter to the first setting above 240 volts AC and check the right and left sides independent from one another to the neutral connection. Each should give a reading of around 120 volts. Now check across the 2 hot connections. You should get a reading of around 240 volts. If you don't, reset the breakers that monitor the range circuit and try it again. If that worked, congratulations. If not, let's keep digging. Each one of the 3 components used in an electric burner circuit can be tested for continuity. Now, if you just thought to yourself, what the heck does that mean? Watch the How to Use a Voltmeter video, and then you'll be up to speed. Remember that when checking for continuity or resistance, the component being tested needs to be disconnected from the rest of the circuit to prevent false readings through some parallel circuit. Because the heating element generates heat through electrical resistance, it should show some resistance when tested for continuity. It should not show as being open or having infinite resistance. The switch that routes electricity to the burner element can be checked in the same way. It should be closed, allowing electricity to flow through to the element whenever the switch is turned on. It should also be open, not allowing electricity to flow whenever the switch is turned off. Remember that with a 240 volt electric range,
it takes 2 to make a thing go right.
2 120 volt circuit connections, that is. So follow the wires back from the element and check each connection independent from the other. L1 input to output, L2 input to output. Most switches are labeled L1 and L2, as well as H1 and H2. You may also see a P terminal. L stands for line or input, and H stands for heater or output. The P terminal generally is the same connection as H1 and is usually used for an indicator light. So, L1 and H1 and L2 and H2 should show contact when the switch is on and nothing when the switch is off. It's always wise to snap a quick picture for reference before you start pulling off wires for your test. An electric range burner switch is a very interesting device. It's often assumed that this style of switch, which is also called an infinite switch, fluctuates the amount of current being supplied to the burner and so controls the amount of heat that is generated by the heating element.